Hello, this is going to be an example video on how to convert between wavelength, frequency, and energy for light. Okay, and so there's some constants that we should be aware of. C is the speed of light, and the speed of light is 3.00 times 10 to the 8th meters per second, right? There's also Planck's constant, which is 6.626 times 10 to the negative 34th joules times second, right? Joules is a unit of energy, okay? Right? So, for example, if we wanted to convert 350 nanometer light to frequency, we have to use the equation, right? The relationship between wavelength and frequency is that the speed of light is equal to the product of that, right? So wavelength times frequency. Remember, lambda, this first character here, is wavelength. And nu, the second character here, is frequency. All right. So if you wanted to solve for frequency, you would divide both sides of the equation by lambda, and so you would get that nu equals c over lambda, right? Frequency is equal to the speed of light divided by the wavelength. Okay, so now we just plug in some numbers, okay? And so first things first, before we plug in the numbers, let's try to make sure our units match up. Here, wavelength is in units of nanometers. So the speed of light is in units of meters, right? So let's convert nanometers over to meters first, okay? 350 nanometers times a conversion factor, right? So we want nanometers on the bottom, meters on the top. And now we want to figure out, all right, how many nanometers are in a meter, okay? Well, the prefix for nano is 10 to the negative 9th. Meter has no prefix, so it's the base prefix, so the magnitude there is 10 to the 0, right? 10 to the 0. So the difference between negative 9 and 0 is 9, right? Is 9. So the magnitude difference is going to be 10 to the 9th, all right? The smaller unit, of course, gets the magnitude difference, so nanometers gets the 10 to the 9th. So there's 10 to the 9th nanometers for every meter. In other words, there's 1 billion nanometers for every meter. Okay? And so if you're doing the math here, you'll get the number of meters in 350 nanometers. That'll be 3.50 times 10 to the 7th meters. Okay? Sorry, not 7th. Should be negative 7, right? Negative 7. Okay, so now we can plug that into our formula, right? So we have 3.00 times 10 to the 8th meters per second divided by 3.50 times 10 to the negative 7th meters per second, right? And so if you're doing the math, you, of course, put this into your calculator, right? We have 3 divided by 3.5 times 10 to the 8th divided by 10 to the negative 7th, and you should get, this is going to be equal to 8.57 times 10 to the 14th 1 over second, right? So since, made an error there, right? There shouldn't be a meter per second there, it should just be meter. So meter is in the numerator up here on the numerator. Meter is also in the numerator in the denominator, so we can actually cancel those out, right? So what we're left with is just the unit 1 over second. You can convince yourself by, of course, doing reciprocals and doing things like that, but we have this. This is going to be the frequency. Remember, we express frequency in units of hertz, right? So 1 over second is functionally equivalent to hertz, right? So we have 8.57 times 10 to the 14th hertz, okay? And that'll be the answer for the frequency. All right, that'll be the answer for the frequency. So, let's do another example where we're converting energy into frequency, right? So, let me create a new screen real quick. All right. So if we wanted to convert a photon, which has a wavelength of, let's do 7.0 times 10 to the 14th hertz, to energy, right? So a photon of 7.0 times 10 to the 14th hertz, light, that frequency of light, and we wanted to convert it to energy, right? Well, we would need the equation, right? Energy is equal to Planck's constant times frequency. In other words, energy is proportional to frequency by Planck's constant. Remember, Planck's constant, right, is 6.626 times 10 to the negative 34th. And again, constants will be provided to you. All right. So there's not much that we have to do. We can just plug in the numbers. So energy is going to be equal to Planck's constant, so 6.626 times 10 to the negative 34th joule seconds, times, right, 7.0 times 10 to the 14th hertz. Okay? Remember, hertz is functionally equivalent to 1 over second. So if we're multiplying the units out, joule times seconds, times 1 over second, well, second times 1 over second, that actually cancels out. Okay? So we're left with the energy unit, joules. All right? So if you do that calculation, you do 6.626 times 10 to the negative 34th times 7.0 times 10 to the 14th. And so you do all that math, you should get 4.6 times 10 to the negative 19th joules. All right. Hopefully that helps. Those are two example calculations for energy and frequency, and then wavelength and frequency. All right. Happy studying, everyone.